So we're going to introduce trigonometry to you in this video, and what we're looking at is trigonometry has to do with ratios of sides in a triangle. So the Pythagorean theorem allows you to find side lengths, but it only allows you to find side lengths if you have a right angle triangle that has two sides already known. And what trigonometry is going to allow us to do is actually find sides based on angles, okay? So trigonometry has to do with angles in a triangle. And so when you look at a triangle, if you label an angle in that triangle, this is theta, it's just a Greek letter, you can label it any way you want, but we tend to use theta for angles, just by convention. Then in that triangle, there are three sides. We know the hypotenuse, you guys already know that about that from the Pythagorean theorem. Okay, so the hypotenuse is always across from the right angle. So you always go right across from the right angle, that's the hypotenuse. But then you also have an opposite side to that angle, the opposite side being the one that's across from it, and the adjacent side, which is the one that is next to it. Okay? And what we do in trigonometry is we define those ratios of sides with three different trig functions. So we call the ratio of opposite over hypotenuse something, the ratio of adjacent over hypotenuse something, and the ratio of opposite over adjacent. And we call them sine, cosine, and tangent. Okay, so this is just definition stuff. You just need to know what these are called. So the ratio of the opposite side, whatever the opposite side length is, to the hypotenuse's side length, we call that sine. And then cosine is adjacent over hypotenuse, and tangent's opposite over adjacent. And really, those are the three ratios that you could have. Now, you can flip them all over. It's possible to have the reciprocals of those, and there are three other trig functions that deal with those, but you don't need to know those right now. We're going to focus on the primary trig ratios, which are sine, cosine, and tangent. So sine of an angle, in this case angle B, in the last case we talked about theta, but you can label them however you want, but this is angle B here, all right, it's colored for you. Then opposite over hypotenuse is sine, adjacent over hypotenuse is cosine, and opposite over adjacent is tangent. And the sort of quick way and easy way to remember that is we call it SOHCAHTOA. Okay, it's just a fun way to remember. Sine is opposite over hypotenuse. Okay, and then we're not going to write out hypotenuse. And then cosine is adjacent over hypotenuse. That's what it's standing for. Okay, hypotenuse, and then tangent is opposite over adjacent. But SOHCAHTOA is an easy way to remember that. So what your job is going to be in terms of trigonometry is, first of all, to be able to identify what side is which. In other words, where's the hypotenuse, where's the opposite side, and where's the adjacent side in reference to the angle that you're looking at. And it's always in reference to the angle. Okay, the hypotenuse is always the hypotenuse. It doesn't change. But the angle that I'm talking about determines the opposite and adjacent side, because, just to show you that, if I now start talking about A, angle A, this is now the opposite side of angle A, right? But this over here is the opposite side of angle B. So it depends on what angle you're talking about, but the sine of whatever angle I'm talking about is always the ratio of opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent's opposite over adjacent. So if we look at this triangle here, we just want to figure out what side is which of the angle Z. So the hypotenuse is always across from the right angle. So the hypotenuse is the side YZ. The opposite side of Z is going to be over here. It's going to be the side XY. And then the adjacent side of Z is the one that it's touching. So it always involves Z. So it's XZ. All right. Same thing down here. The hypotenuse is going to be across from the right angle, right? I always draw in arrows from the angle down. That's the opposite side. So that, I know I'm jumping, but that's IU. And then the HU is the hypotenuse, and then the adjacent side is HI. All right? So that's the idea. If you look at this, this gives us the sides, and it just says, what is sine of K, cosine of K, and tangent of K? So here's K. The first thing I try to do is identify what are the sides, right? What are we talking about in terms of opposite, adjacent, and hypotenuse? So this is the hypotenuse. This is H. And this is the opposite side, which leaves that to be the adjacent side. So now sine is opposite over adjacent, so it's over hypotenuse. So it's 4 is the opposite side over the hypotenuse. Hypotenuse is 5. So the sine is 4/5. Cosine is adjacent over hypotenuse, so it's going to be 3 over 5. And opposite over adjacent is 4 over 3. So tangent is 4 over 3. Okay, if we look at this question, it says which ratio represents cosine of A? Here's A. Cosine, remember, so katoa, so we're talking about adjacent over hypotenuse. So the adjacent side is 5, and the hypotenuse is 13. Okay, that's the hypotenuse, and that's the adjacent side. So the adjacent over the hypotenuse is 5 over 13, so my answer is 1. If you look at this question, it says which represents sine of P? Sine is the so in SOHCAHTOA, so I'm looking for the opposite side to P, which is here, and the hypotenuse, which is across from the right angle. So the sine of angle P is going to be opposite over hypotenuse, which in this case is 6 over 10, and so that's my answer. Right, now this question says, in the accompanied diagram, what's tangent of C? So here's angle C. Tangent is the TOA part. So that means it's opposite over adjacent. So this side here, you go across, that's the opposite side. And 15 is the adjacent side because this is the hypotenuse, all right? So tangent is going to be opposite, which is 8, over adjacent, which is 15. So the answer is 8 over 15, okay? Here, we're asked for the sine of x. The sine of x, again, sine is the so it's opposite, which is this side, over the hypotenuse, which is this side, because it's across from the right angle. So sine of x is going to be opposite over hypotenuse, which is 8 over 15. Okay, so that's my answer. This question says, here's the angle L, all right, and it wants to know sine, cosine, and tangent. So the first thing I'm going to do is identify that's the opposite side, this is the adjacent side, and this is the hypotenuse. So sine of L is opposite over hypotenuse, so it's going to be 6 over 10, or you could reduce that to 3 over 5 if you want to divide them both by 2. Cosine of L is adjacent over hypotenuse, so it's going to be 8 over 10, which again, if you want to, reduces to 4 over 5. And then tangent of L is opposite over adjacent. So the opposite side is 6 and the adjacent side is 8. So that reduces to 3 over 4. Okay? Now if you look down here, same idea. Here's angle A. So this, again, across from that is opposite. Touching it is adjacent. And then the right angle across from that is the hypotenuse. So sine of A is going to be opposite over hypotenuse. So 12 over 13. Cosine of A is adjacent over hypotenuse, which is 9 over 13. And tangent of A is opposite over adjacent, so 12 over 9, which that actually reduces if you divide them by 3 to 4/3. All right. Now this question doesn't actually give us the triangle. It just says in triangle this. So we're going to draw a triangle. Okay. We're going to put a right angle in it. It says the right angle is angle Y. So here's Y. So we'll go X, Y, and then we'll put Z here. It tells us that XZ is 25. It tells us that XY is 7. And it tells us that YZ is 24. And it says, what's the cosine of X? So here's the cosine of X. So we want the adjacent side. And we want the hypotenuse, right? Because it's the ka part. Cosine is adjacent over hypotenuse. So cosine of X then is going to be adjacent over hypotenuse. We know the hypotenuse is 25. The adjacent side is 7. So it's going to be 7 over 25. Okay? Which is that guy. And the same thing happens here. It gives me a triangle. This angle T, it says, is 90 degrees. And then, so this will be M, this will be C. It says this is 85, this is 84. Sorry, this is 84. Angle, or side CT is 84. And then, whoops, I didn't want to do that. Let me make this a little bit smaller here. There we go. And then TM is 13. So I have this, and it wants sine of C. So this is the angle I'm talking about. So I want the opposite side, okay, and then I want the hypotenuse, because sine is opposite over hypotenuse. So when we do that, the sine of angle C then is opposite over hypotenuse, which is going to be 13 over 85. Okay, so that's this option. So that's the idea. That's a basic introduction to trigonometry and the primary trig ratios. In the next video, we're going to talk about what do we do with them.